Welcome guys, this is questions and solution on standard form based on our scheme of work. So look at standard form, what are the things or the questions that you may likely find or you may likely be given in standard form to solve. Now the note is here, so this note says that let's define what standard form is. So it's a way of expressing numbers in the form of a times 10 raised to the power of a number. It means when you are expressing a number in standard form, it may be in ordinary form, at times it will be in a form of times 10 raised to the power something, but it's not actually in standard form. So to make a number in standard form, another number in standard form, that will be times 10 times 10. Then raised to the power can be a negative, it can be a positive. So I'm not going to dwell much on this note. My explanation will give an insight on what this note is all about and how you can do things. I will attach this note to this video so you can have the soft copy, but I will advise you, as I'm solving, you also solve on your own, and you can pause the video. Any question to solve, you can pause to try it on your own. If you didn't solve it right, then my solution, you should be able to get it. Now let's move to the main work now. Now let's assume now you are given something to change to standard form. Now let's assume you are given something like this. That's to change this to standard form. You are given, let's say you have 2, 3, 4, 1. You have to change it to standard form. Now in standard form, there is something you have to know. There must only be one digit number before the decimal point. That is standard form for me. And in this one, you notice that there is no decimal point in this number here. Now you assume that the decimal point is at the last number here. So what you have to do is that you move this invisible decimal point to only one number before decimal point. It means this number, let me change this my pen here. Now it means this this decimal point, invisible decimal point that is here, have to move it to the front of 2. So I'll move it like this: 1, 2, 3. So it means my decimal points have to be here. That is it. There must only be a digit number before decimal point. So I have to move my point, invisible decimal point. I have to move it here. So when I move, when I counted, this is 1, 2, 3. So my answer now will be what? 2.341 times 10 raised to the power. How many times do you move? You move backward how many times? 1, 2, 3. You move 3. So it's going to be what? You're going to write 3 here. So that is the final answer. That's how to express number in standard form. Let's look at another number. Let's look at another one. So let's assume you are given something like this. What if you are given something like this? 423.65. Now when you check this, you can see that there are only 3 numbers before the decimal point, and for standard form there must only be a single digit number before decimal point. So I have to move decimal point to where it has to be. So it has to be at the front of 4. So when I count, I'll go like this: 1, 2. So it has to come here. So my final answer will now be what? 4.2365 times, you must multiply by 10, is a must, times 10. Then how many times do you move? You move what? 1, 2. So you put 2 at the top of it. That is that. So let's assume you are given for another. Let's say you are given something like this. Let's look at 0 point. Let's say you have 0.00472. Now this number here are numbers less than 1. So anytime an ordinary number start from 0 point, it means you are going to have a negative power to the of the 10. Now what I'm saying here is that you see this point, it is not actually where it should be now. It has to move to the first number that is not 0 in front of the first number that is not 0. So I have to move it there. So I have to move it 1, 2, 3. I have to stop here because this is the 4 is the first number that is not 0. So first number that is 4, I have to move to the front of it, that is 4. So it will be 4.7 2 times 10 raised power. Now, because this thing starts from 0 point, so you have to make it a negative number. That will be 1, 2, 3. That is what? 10 raised power what? Minus 3. So that is that. That is for this one. Let's look at the question under another question under the solving. Now we have another questions there. Let me see if you can grab some questions there. Okay, so we've done this. Let's look at another. Let's say you have, okay, now let's look at this one. This one they give us we have 4 points there. This one you have 4.81. They also changes to standard form. Like this now, it has satisfied the rule of standard form. There's only a single digit number before decimal point. So when you look at this now, so the answer will now be what? It's still what? 4.81 times 10 raised to the power of. Now when you check very well now, you can see there is no movements at all. So it will be 0. So that is the rules there. And now let's look at some question together. So I'm going to get some question here. I want to get some question. Permit me for doing this. Let me get some question and we solve it together. Okay, now let's move down here. Okay, there's a question here. Let's look at this question. Let me use these things to snap it off so that we can do it together. So we have something like this. They have to make it in standard form. This is addition and subtraction in standard form. It's common. You always see something like this. You may see it in your. Now, can I scroll this? So let me move to the next page. Sorry. Let me set the background to okay. Then let me make it more bold so that you can see it clearly. Then change my marker to white. Now, so this is the question I want us to solve together. It's the question. Now, in this question, they said evaluate the following in standard form. Now, this is additional. Now, how do you go about this now? So you have, this is what you are given. You have 4.72 times 10 raised to the power of 3 plus 3.648 times 10 raised to the power of 3. Now, they are in standard form like this. It's very easy. But what you're going to do is that because both of them have the power of base of 10 raised to the power 3, so you can just pick one of them. You pick one of the base number. So you now add this and this together. So if I want to add this, I will have 4.72 plus, so I want to add this with this one. That will be 3.648. Now in this space, since this place is empty, you put 0 there. So addition, just add 0 plus 8 is 8, 2 plus 4 is 6, 7 plus 6 is 13, you keep 1, right? 4 plus 3 is 7 plus 1 is what? Is 8. So you can recall that both of them have 10, 10, so you pick one of the 10 times 10 raised to the power what? 10 raised to the power of what? 10 raised to the power of 3. So that is it. So your answer is 8.368 times 10 raised to the power 3. This is how you solve this. Now look at the second one. You have 6.4 to 6.142 times 10 raised to the power of 5 plus 3.648 times 10 raised to the power of 3. So I'm managing space. Now, in this now, you can see that, okay, 6.14 times 5. Okay, this time is 10 raised to the power of 4. Sorry. So let me just erase this off so that there will be enough space for us. So now this is 10 raised to the power of 4 here. Now, what you're going to do here is that you pick the lowest one between 10 raised to the power 5 and 10 raised to the power 4 is 10 raised to the power 4, right? Because 10 raised to the power 5 is bigger than 10 raised to the power 4. So when you take away 5 from 4, you still have 1. So in this one, what you have is you still have 6.142 times 10 raised to the power of 1. Just note that. Plus 3.648. Now, because you have taken 4 minus 4 is 0, there's nothing remaining. You have taken, because the smallest one is 10 to the power 4, so this one there's no remainder. Here there will be a remainder of 1 because 4 minus 1 is still 1. So everything will be times 10 to the power what? Times 10 to the power of 4. Times 10 to the power of 4. Now what you're going to do is that you convert this number here. This one is in standard form. You convert it to normal form, the ordinary form. So since what is there is raised to the power 1, you move this point, you move it forward once. This is minus 1, you move it backward once. So this 1 that is there, so you move this point, you move it 1. So to move to the point of this one here. So what we have now, we have was 61.42. Then you are adding into what? 3.648 plus 3. In addition, the points have to be aligned. 6, 4, 8. Now I told you there you put what? You put 0 here. So when you add them up together, 8 plus 0 is what? Is 8. 4 plus 2 is 6. Now 6 plus 4 is 10. You write 0, you keep 1. 1 plus 3 is 4, plus 1 is what? Is 5. Then you have what? 6, right? So this is what you have. Let me scroll down. So you have 6, 5.068 times 10 raised to the power of what? 10 raised to the power of 4. Now when you look at this very well, it has not satisfied the rule of standard form because only one digit number must be before the decimal point. So it means I have to change this one also to decimal point. So I have to move this one. You move it to what? You move it to the normal place it should be. You move it here. So it becomes 6.5068 times 10 raised to the power of what? 10 raised to the power of 1 because you move once. So with this one also times what? Times 10 raised to the power of what? 10 raised to the power of 4. You can see we have 10, 10, and the rules of multiplication in indices, you add the power up. You add them up together. You add the power. You pick one of the 10. You add the power together. That will be 1 plus 4, which is 5. So your final answer will now be 6.5068 times 10 raised to the power of what? 10 raised to the power of what? 10 raised to the power of 5. But if you are very good at what you're doing, since you move this thing once, just add 1 to this for making what? Making 5. So that is that for that. Now let's look at the last one. So the last one here, this place is filled up. Let me just copy this. Let me open another page so that you can set the background. Sorry, I won't take your time. We still have lots to do here. So let me just use 100. Sorry for this. It's just I don't know why it's not showing. Okay, what I will do is that I will go there and just like copy the question. I think the question is saying that 7.113 times 10 to the power minus 4. Let's do it together. 7.113. Saying 7.113 times 10 to the power minus 4. Dispenser. So we have 7.113 times 10 raised to the power minus 4 minus, I think the minus there, I think is in this particular book, minus minus 8.13 times 10 raised to the power minus 6 minus 8.13 minus 8.13 times 10 raised to the power minus 6. So I think here is minus 5. Sorry. Here is minus 5. So here you have what? Minus what? Minus 5 here. The same thing applies there. So what you're going to do is that you pick the is it 7 points? You pick the smallest one here. So you pick the smallest one. The smallest one here is minus 5. When you check, it's not the biggest one is minus 5. Because minus always, but just assume at your for your own level 5 is smaller than 6, but minus 5 is bigger than minus 6. So you pick the smallest, just assume you pick the smallest one, which is minus 5. You pick it here. So you have what you have left. You have 7.113 times 10 raised to the power. When you take this one is off. Yes, it's off because you have done justice to this. So you have minus 5. When you pick 10 raised to the power minus 5, there's nothing remaining. So you have minus. Here you have 8.13 times, when you take minus 5 from minus 6, you still have minus 1 left, right? So everything was times 10 raised to the power, because you pick times 10 raised to the power minus 5, the smallest one, the biggest one, how you might call it, that is it. So this is, use this because of 5, this one is 6, you pick this one which is 5, then you still have 1 left here, that is the one that is there. So in this, you convert this one to ordinary number. So we have 7.113 minus, so this is minus 1. If it's minus, you are moving backward, but if it's plus, you are moving forward. So this is minus 1. So this point here, you move it back once, so it's going to come here. So you have points here. So what you have, you now have what? Anything, if you have 0.832, it means 0.832. That's what it means. So it means this one now, when you take this point here, you have 0.813. So your answer will be what? 0.813, right? When you close it, times what? Times 10 raised to the power what? 10 raised to the power minus 5. Using our normal protocol, so you have 7.113 minus 0.813. So when you minus this, 3 minus 3 is 0, 1 minus 1 is 0. You borrow 1 from here, bring it here, that is 11. 11 minus 8, that is 3. Then 7, 6, there's minus 6 here when you borrow 1, so you have 6. So that is 6.300. So it's the same thing as saying 6.3 times 10 raised to the power what? 10 raised to the power what is here? Minus 5. So that is that for this one. That is the final answer. So let's look at some wire question from this chapter, from this notes that we solved together with standard form. The questions are here. Okay, the questions are here. Let me just snap it, then you solve it together. Okay, I hope this will not take us time. I just hope so. So you copy, so go here, let me clear this frame, I don't need it. Okay, let me clear it, so let me paste this there. Okay, I think you can see the question clearly. Yeah, since you can see the question clearly, very well, they can see it. Now, so let me reduce this. I can still expand it. Let me just reduce it. I'll write it again. Now the first one they said you should what? You should make this in what? In standard form. You have 0.0.003 0 0.075 times 4, right? So I can just use my normal notion one work. Now 4 times 5 is 20, you keep 2. 4 times 2 is 28, plus 2 is 30, you keep 3. 4 times 0 is 0, you write your 3 there, right? 4 times 0 is what? Is 0. 4 times 3 is 12. You write 2, you keep what? You keep 1. 4 times 0 is 0, plus that 1. 4 times 0, that is 0. Then your point, then your 0. So I told you earlier, this is negative because started from 0 point. So you have to move this point to the first number that is not 0, in front of the first number that is not 0. So I will move this thing like this. So it's going to go like this: 1, then 2. So my point has to come here. So my final answer here is what? 1.20300. Can ignore the 0 at the back, no problem. How many times you move? You move 1, 2. You move twice. 10 raised power. It will not be 2, it will be minus 2 because you're starting from 0 points. That is that for that. Now the second one also, that one is straightforward. You have to convert this to standard form: 0.00703 to standard form. So this is number 1 and this is number what? Number 2. So how do you go about this now? The same thing you're going to do, you move this point to the first number that is not 0, that is front of 7, that you count 1, 2, 3. So it will move here. So this is where the point will be. So your final answer will be what? 7.023 times 10 raised power what? 10 raised power what? How many times do you move thrice? Minus 3, because started from what? 0 points. Now the next one I said express the product of 0.06 and 0.09 in standard form. At times they will give you this in if it's in objective, it's very easy, just multiply them together. But if it's theory question, they will ask you to solve, so you have to see your solving. If you use calculator, they will know. So I want to, so that you will be able to understand how it goes, so that I don't want to use normal calculator. So let's do this together. So I can turn this 0.06 to standard form. So we have 0.06 to standard form. I have to move this point here. That will be 1, 2, right? I move twice now. 1, 2. So this will be 6 times 10 raised power what? How many times you move? Minus 2, right? What is there? Product means times. Times. The second one also is 0.09. We move twice. 1, 2. That is what we have is 0.09. 0.09. When I move twice also, I'll have 1, 2 twice. That will be 9, because my point is 9 here. You don't need to write anything. That is 10 raised power what? Minus 2. So this one will be what? 9. Multiplying this now times 10 raised power what? 10 raised power minus 2. So 9 times 6, 9 times 5 is 45, and 9 times 6, that should give us 54. So 9 times 6 is 54. So we have, you multiply this number 6 times 9, that is 54. 54. Now I want to show you something now. Now note this one also, you will multiply by this one. So that will be what? Times what? 10 raised power. I should not be doing this, but let me just do it for you so that you'll be able to understand what you are doing. Times what? 10 raised power what? Minus 2. Now 5.4, 54, that would be what? 54, right? This is it, right? Times. Now this one here, there's an invisible plus there. Anytime you have times, you have the same base, 10, 10, you pick one of the base. Laws of indices, once you have times, the power you're going to add them together, that is minus 2 plus minus 2. So minus 2 plus minus 2 means, that will be, let me just do it here for you. Minus 2 plus minus 2. So this you have to make them 1. So you have to multiply this together. Plus times minus is what? Is minus. So you have minus 2 minus 2. So minus 2 minus 2 is minus 4. So here you have, let me write it here, 54 times 10 raised power what? 10 raised power minus 4. But this is not our final answer. I told you earlier that in standard form, a number, we only want a digit number before decimal points. And I told you that if you have ordinary number that does not have decimal points, the point is at the last number. There's an invisible point here, which is not seen by. So you have to move this point, you have to move it here. That is where it should be. And note that this one does not have a 0 point, so it will be positive power. So you have to move this what? You move it to what? Here's 1. So points. So you now have what? 5.4 times 10 raised to power 1, because you converted this to standard form. This is it here. Then times what? Times 10 raised to power what? Minus 4. So the final answer would now be 5.4 times 1 plus minus 4 is 1 minus 4. So 1 minus 4 will give us what? Minus 3. So this is minus 3. So this is your final answer if you have to solve without using what? Without using calculator. So you can put this down, you can put it down. So put it down. I want to see, just put it down. Let me see before I clean it. Pause the video and put it down. Oh, let me just, I don't want to waste time here. This is wasting time, but no problem. We're still gonna get there. Just clean some parts. I'm okay with others. Let me just clean this part. This one will solve the remaining. Now, the next one, as I said, just now simplify in standard form also. So here we have, you have 16 times 10 raised to power what? 10 raised to power of 5. Is it 5 or minus 5? Minus 5, sorry, minus 5 divided by 4 times 10 raised to power of what? Minus 6. Let me show you what to do now. For this one is very easy, because 4 here is 1, 4 goes in 16, it is 4. Now the problem now is this now. So if I were you, I would just write 4, because 4 over 1 is still 4, times, you have the top number 10 raised to power minus 5 divided by, because it's division now, not times, this thing means division, times what? Divided by what? 10 raised to power what? 10 raised to power minus 6. So how do you solve this now? Not in division, if it's division, you pick one of the what? One of the base. The base is 10, you pick one of the base. Now division is minus, multiplication is plus, so here will be minus at the top here. So you have minus 5 minus 6. That's what you have there. So you have what? 4 times what? Minus 5, 10 raised to power what? Minus 5. Minus times minus is what? Is plus. Plus what? Plus 6. So minus 5 plus 6, that should give us 1. 10 raised to power what? 10 raised to power 1. So this is your final answer. Now let's look at this one. And they said to find the value of this, they give you something like this. So how do you solve it? You have I think we are getting to the complex part now. So pause this video and copy this particular exercise. I don't want to move to the next because of the question. Sorry for this time wastage. Now let's go down. Now the other one now, this is now square root. It's getting complex now. You have square root. They give you square root of this. So you have 0.00196 times 2.25 over 62.5. Now in a case like this, they will ask in WAEC that neither use calculator nor logarithm table or four-figure table. So you have to solve it for them and show your workings. If you use calculator, they will know, and you get it wrong. Now what you have to do here, what I do tell my students is that you move these points to the last number here. Don't make it in a you make it in standard form here. it's going to give you problem. So I will advise you to move this point to the last number. So I will move this thing to the last number so that this thing can be a whole number. I'll be able to divide it. It will be easier for me to divide. Now you move this thing, you move it to 1, 2, 3, 4, 5. So it means here you have square root. You have 196 times 10 raised to power what? You move 5 times, minus 5. Now times this one also, you move also 1, 2. That was 225 times 10 raised to power what? Minus 2. You can see that it is very easy for me to divide because of this whole number divided by, so I have to move this also 1. So when I move it 1, you have 625 times what? Times 10 raised to power what? 10 raised to power what? 10 raised to power minus, is it minus 1? No, that's not, sorry. This one, it does not start from decimal point. There was a mistake. It does not start from decimal point. It does not start from 0 points, I mean. So it should be plus 2. Sorry for this. This will be plus 2. This also be what? This also be what? Plus 1. So it will not be minus 1. Or let's start from 0 points. Now what we're going to do now is that if I were you, I'll multiply the numbers together. So 196 times 225 divided by 625. You can do this, or you can say 625 divided by 225 divided by 625. Let's look at it. Let me bring out my calculator. Okay, sorry for this. So I can do like this. So I can use my calculator. 625 divided by, I think it's divided by 125. 125. So what did I get? So that gave me 5. So use this. So here it means, is it 125? Sorry. Oh my god. So we have 625 divided by 225. So that should give us what? Oh, that is 2.7777. No, I don't want to do that. Now what I'll do here is that to make things easier for us is that I can multiply this 196 times 225, then divide it by 625. Let's do that. So you can have it like this. 196 times what? Times 225. That will give us divided by what? Divided by 625. 625. It's permitted like this. So when you do this, you have 70.56 as an answer here. So it means here, this is what I did here. I did 196 times what? 225 divided by what? Divided by 625. So I have what? 70.56. I think if I'm right. So that should not make, okay, 70.56. So we have 70.56. Now we are not going to deal with the base 10 number. This is minus 5. I told that there's an invisible plus here. So minus 5 plus 2. Minus 5 plus 2. Plus times plus is plus. Minus 5 plus 2 give us minus 3. So this is 10 raised to power what? The top one will be 10 raised to power minus 3. Now you know over means division. Divided by what? 10 raised to power what? 10 raised to power 1. So also here is what? You know here is minus here because it's a division now. So it will be minus 3 minus 1. That is minus 4. So we have 70.56 times 10 raised to power what? 10 raised to power minus 4. Now, I told you this thing is not in standard form because you have to move, this point has to come here, only first digit number. So it means I have to move this point here. And I'll move it backward here because it's a positive number, it doesn't have a 0 point, it's plus. I can just add plus 1 here. So it will be what? 7.056 times 10 raised to power minus 4 plus 1 because I moved backward once, but because it starts from 70 point, not 0 point, So my answer will now be 70.056 times minus 4 plus 1 is what? Minus 3. 10 raised to the power what? Minus 3. So this is your what? Your final answer. So let's move on to the what? To the number 7. Number 7, you can pause the video and copy the solution, or you can do the number 7 by yourself. Pause the video and do the number 7. Let me see how well you how well you understand what you'll be doing. I'll be very happy if you can do it without my assistance. Now let's move on. I don't like doing this, but I have to do it. I will find a way to just know how to do this. Just like I'm done. Okay, so let's move on. Now the next one now is that we want to look at this. They gave us something like this. We have 0.016 times 0.084 over 0.48. So now 0.48, I think I did a mistake in that one I did there. There was a mistake, but I will know what to do. There was a mistake in that one. You know we are looking for square roots. I did not look for the square root of it, but we'll go about. I'll know how we can go. But I think we get 70 point something, 7.56 times 10 raised to the power. So our last question here, sorry, there was a mistake here. What we got here, we got before I did my stuff, we got 70.56 times what? Times 10 raised to the power what? 10 raised to the power, is it minus 4 what? Is it minus 4? Let me check here if I can get it there. 1 2 3 4 5 1 2 5 minus 3. 5 minus 3 is minus, that is minus 5 minus 3. 5 minus 2, that is minus 3. 1 2 3 4 5 minus 3. Then here that is minus 2. So we got something like this. That's what we get. Because when we move here, okay, minus, that is minus 3 here. So we have minus 3 here. Because here is minus 3. 3 4 minus 5 plus 2 is minus 3. Then there you have minus 3. Here is plus 1. Then is minus 3 minus 1, that is minus 4. We got something like this here. This is what we get. Sorry, we have to look for the square root. I mean, this previous one I did before I clean it, this is what we get. So you have to look for the square root. Pardon me for doing that. Now the square root of 70.56. So in a base number, the square root, you are going to divide the power by 2. Well, you can look for the square root of this. So 70.56, let me look for the square root here. Square root of what? 70.56. 70. Okay, sorry. So let me type 70.56. Sorry for this. I shouldn't do it. So we got 8.4. So it's 8.4 here. So for the previous one, so we have what? 8.4. When we look for the square root of this, 8.4 times. Now this 10 raised to the power minus 4. This thing means 2. That's what it means. But we don't write it as a mathematician. So you have to divide this one. When you have something like this, you divide this by 2 because of what? Of this square root. So minus 4 divided by 2 is minus 2. 10 raised to the power what? 10 raised to the power minus 2. So this will be our final answer for the previous work. You cannot stop here. These are 70.56 times 10 to the power 4. I move forward, move backward, then plus 1. I got 7.05 times 10 to the power minus 3. But you have to look for the square root. So this is your final answer. Please pardon me for that. It's escaped my mind, but sorry for that. We are on track. Sorry for what I did here. Very sorry. Now let's move on. Now I feel playing down. I hope to get through this. Damn, giving me stress. Now let's move on. Now this one doesn't have. I will be very careful now. This one doesn't have. So we have 0.0 0.016 times 0.0884 over, now we have what, 0.48. 0.48. Now what I said earlier is that you make this thing in ordinary form to make it easier for you, take to ordinary form. Now you have 1, 2, 3. So the first one is going to be 16. You take the decimal point, last number here, so that it will be easier for you to divide. Unless you are not using, it's an objective question. But if it's theory, you have to do it like this, because the examiner will know what you are doing. He must see you're working. He or she must see you're working. Now minus 3 times this one also, you count 1, 2, 3. So that will be what? 84 times what? 10 raised to the power what? 10 raised to the power minus 3 all over, divided by this one, we count twice, 1, 2, 48. You can recall that the reason why I'm using minus is that it started from 0 point, so minus 2. So I can divide this thing, I can do it like this. Now 16 here is what? 16 here is what? Is 1. 16 48, I think it's 3 if I'm right. Can 3 go here? Let's check. 3 can be able to go here. 3 here is what? Is 1. 3 in 8 is 2. 3 times 2 is 6, mean that 2. 3 in 24 is what? 3 times 6 is 24, that is 26. It means when you divide all the number, you have 26. Then let's deal with the base 10 number. So we have 10 raised to the power what? Minus 3 times this one also, 10 raised to the power what? Minus 3. Now this is over, means division, divided by 10 raised to the power what? Minus 2. So looking at it together, so we have 26 times, now minus 3 plus minus 3 is minus 6, just like saying, because plus doesn't have effect at all. So minus 3 minus 3 is minus 6. So we have 10 raised to the power what? Minus 6. Then here is also minus, so we have minus 2, minus 2. So we have 26 times 10 raised to the power minus 6 minus minus. This minus times minus, you have to multiply it. Minus times minus will give us what? Will give us plus. So minus 6 plus 2. You are owing someone 6 naira, you are having 2 naira. If you pay, you are still owing what? You are still owing 4 naira. That is it. So I told you that this thing is not in standard form. You have to take this divisible decimal point, you bring it here. Only one digit number before decimal point. That would be 2.6. I want to stress you again, times 10 raised to the power. So I told you that you add plus 1 here because you move once. So it will be what? Minus 4 plus 1. So here will be what? 2.6 times 10 raised to the power minus 3. I think you are getting it now very well. So the last one now, before we call this lesson, before we kiss this lesson goodbye. Now the last one, I think, is also very, very simple. You can be able to do the last one by yourself. I want you to try it on your own. If you cannot try it, then no problem, I will solve it for you. Now let's solve it together. Now the last one, now we have they gave us 1.25 times, is it times 10 raised to the power? Let me check this thing because it's more of like, it's blurry. Okay, times 10 raised to the power 8. Okay, times 10 raised to the power 8, and this times 10. Okay, sorry. So this is times what? Times 10 raised to the power of what? 10 raised to the power of 8 times 2 times 10 raised to the power of 2.0 is the same thing as 2 minus 2 all over, you are dividing by what? 6.25 times 10 raised to the power of what? 10 raised to the power of 4. Now what you're going to do here is that, as I said earlier, you can multiply 125 times 2 divided by 625. But I will advise you, if it's a theory question, don't do that. Examiner will know. So this means I have to take this point to the last number. So I will count 1, 2. That'll be 1.125. That is 125. I move twice forward. That will be times 10 raised to the power 2. I'm not gonna kill like this. Then times what? This 10 raised to the power 8. 10 raised to the power 8. I'm just converting this into ordinary form. Believe me, just want to ordinary form. That is why it's 10 raised to the power 2. Because if you are converting to standard form, you know invisible point will be here. You count backward 1, 2, you still get back this thing. Do you get that now? That is the logic. Now, so this is then times what? Times 2 times 10 raised to the power what? 10 raised to the power minus 10 raised to the power what? Minus 2 all over now. What do we now have now? We have what? You count also 1, 2. That is 625 times 10 raised to the power 2 times what? 10 raised to the power what? 10 raised to the power 4. Now, with this now, our problem is solved now. So the tens are the same thing. So 125 times 2, so that will give us 250, right? That is 250 times this one is just addition. 2 plus 8 is 10. Then 10, no, 10, this is minus, plus, no, plus and minus minus. 2 plus 8, 10, 10 minus 2, that is what? That is 8. So that is 8. 10 raised to the power what? 8, right? Divided by, so we have 625 times this one also, that is 2 plus 4, that is 6. 10 raised to the power what? 10 raised to the power 6. So I'm going to use my calculator. 250 divided by 25. You can do that, but you can use normal method. 250 divided by 25 divided by 625. Sorry, 625. Let me make a mistake. So that will give us what? That should give us 0.4. So that gives us 0.4. So it means here is what we have, what? 0.4 times, now this 10 raised to the power 8, 10 raised to the power 8, then over means divided by what? 10 raised to the power what? 10 raised to the power of what? 10 raised to the power of 10 raised to the power of 6. Now division, I told you to be what? Minus. So you have 0.4 times 8 minus 6, that is what? That is 2. 10 raised to the power of what? 2. But this is not in standard form. That's to go to the front of the first number is not 0. So you move this point to the front. That would be what? 4 times, because this thing is 0 point, it has to be minus 1. So it will be 10 what? 10 raised to the power 2 minus 1. Do you get that now? Assuming it's a 94 point something. If it's not 0 points, there's other numbers you plus. But this one is 0 points, is minus. So I want to minus it from 1 because you move how many times? Once. So it means your final answer now give us what? 4 times 10 raised to the power 2 minus 1 is what? That is 1. So this is your final answer if you are using normal method to solve. So that is the end of this lesson. We move to the next one where we move to logarithm. Move to Matizza, characteristics, and how you can solve logarithmic problem using 4-figure table. So I want you to have your understanding of this standard form. Good luck. See you in our next class. Bye. Now in this, we're going to look at approximating value to the nearest whole number and decimal place. Then after this, we move to approximating values to significant figure. So let's take it bit by bit. Now when you say decimal places, it means after decimal points, what are the numbers I want to show, or I want to display, or I want you to write. That is what decimal place is talking about. And nearest whole number is just the number before decimal place. Let's look at this now. Let's assume they said, they gave something like this. They said, let me change this my marker so that you can see it clearly. Let's assume we are given something like this. They said you should approximate this value to, let's say we have 22.45 to everything to nearest whole number. Approximate approximate to nearest whole number. That is the first one we are going to look at. Now, you have approximate to nearest whole number. There is something you have to know in rounding up and rounding down. If a number is from 0 to 4, you round down. You what? You round down. You round down. And when you are rounding down, it means you turn that number to 0. So the number will be what? Will be 0. If the number is from 5 to 9, you are going to round up. You what? You round up. So when you're rounding up, it means you turn that number to 1. That is what rounding up means. Now for this one, they say you round it up to nearest whole number. What number means number before decimal point. It means you just need only this number here. That is what you need here. Only 22. But before you choose 22, no, this 2 is the one that ends this 22 here. You check this next number. Is it up to 5? Are you going to round down or are you going to round up? This number here, it is 4. It is not even up to 5. So it's going to be 0. So what it means everything here is going to be 0, 0. Because you are checking the number next to it. You are not checking this one. Mistake students do make is that they will check they'll make this one, they'll round it up to 1, they'll add this one making 5, they now round it up to 1 again, to add this one making 23. No, we check the next number after it. You are not concerned about the number that follows this after that one. So that is rounding up for you. So in this particular example now, so the nearest whole number, I'm going to round it up to what? So the nearest whole number, you're rounding up this thing is what? Is 22. That is your final answer. Let's assume you are given something like this. You gave something like this is 0.97. You are asked to what? To round it up to nearest whole number. This is approximation sign. Nearest whole number, when you check, this is what you need. This 0 here. But to check the next number, is it up to 5? Yes, it's more than 5. So, and our rules say that if it's from 5 to 9, you round up, you turn it to 1. So it means this 9 will become 1. You now add it to this 0, making what? Making 1. So 1 is your final answer. Did you get that logic now? Let's assume they give me another one. Let's say you have like, they gave you 129 point, let's say 0.8. They ask you to what? Round up this number to nearest whole number. To round it up to nearest number, you know this 8 is up to 1, right? You are going to add it up to this one. But you now say, am I going to write 10 here? No, you are not going to write 10. You take this 29 as tens. Because of this 9, assuming it's 8, you can just add it to make it 29. But because it has reached the end of what? Rounding up. So you are going to take this as 29. So it means this one is up to 5. Yeah, you round it up, you turn it to 1. 1 plus 29 now is what? 30. So your answer is 130. Do you get the logic? Now let's look at another one. Let's assume you are given something like this. We have 299.65. Now look at this one. So what do you think the answer will be? Now you know this is what you care about. Nearest whole number now. Now this is 99. After 99, when you add 1 to making 100, but you cannot write 100. It's not possible. So you're going to take this 3 value. This is 299. So make this one to become what? To become 1. You add it to 299, making what? 300. 299 plus 1 is 300. So nearest whole number here is what? It is what? 300. Did you get that what? Did you get that? Let me do another example so that I want you to understand this nearest whole number. Let's assume you're given something like this. Let's say you have 52.08. You have to round it up to nearest whole number. What will be the answer? Your answer, this one is not up to 5, so this is only what you need. This is what? This is just 52. Did you get the logic now? So this is how whole number, to round a number up to the nearest what? Nearest whole number. So let's move on. Now let's assume now they ask you to round off a number to decimal place. Now this is where it gets funky. Now to decimal place, So sorry for the breakup. I have to just attend to an issue. Sorry for that. Sorry. Let me fix my mic. Sorry for this particular delay. Okay, let's move on to what I'm saying. Now in let me zoom this thing so that you can see what I'm writing clearly. Okay, now in when you are rounding off the number to decimal place, they are telling you that after decimal points, no matter the number, I just want to see some numbers. Let's assume they said round up the following to the decimal places given. Now let's assume you are given something like this. This is the number you are given. Again, instead you should round off. Let's assume you are rounding off 0.0786. You're rounding it off to, let's say, they said 2 decimal places, 3 decimal places, and 1 decimal places. So how do you round up this now? So 2 decimal places means after decimal point 2, I want to see only 2 numbers. That is what it means. So it means in this one now, your final answer here will be, so 2 decimal places will be 0. What are the numbers? Is 0 and 3 is 1, this is 2, you stop here. But now I told you earlier, you check the next number, is 0 up to 5? Is up to 5 is 8. So you make it what? You make it 1. You make this 8 to be 1. You now add it to this 7, making 8. So your answer here is what? 0.08. That is what? 2 decimal places. If it's 3 decimal places, you know what will be? This will be 1, 2, 3. You stop here. You check the next number. Is it up to 5? Yes, it's up to 5. You make it what? 1. You add it to this 8, making what? 9. So to 3 decimal places, that is 0.079. So this is 3 what? 3 decimal place. Now, 1 decimal place now. This is where you have to stop. 1 decimal place, you write 0 points. That is very short. Now, 1 decimal place, you stop here. This is what only 1 number after decimal point. But you check the next number, is up to 5? It's up to 5. You make it what? You make it 1. Add it to this 0, making what? Making 1. So this is what? 1 decimal place. So that is that for that. Now let's look at another one again. Let's assume you are giving something like this. You are given 7.9. This is 7.926. You have to round up to 2 decimal, 3 decimal, and 1 decimal places. Now to 2 decimal places, this is just it. Let me add 1 to this, making 4. This is 1, 2, you stop here, Abby. But this is up to 5. You make it 1, add to 1, make it 1, 3. So first thing you have to write this thing down. That one is very short. 7 points. Then that will be 9 what? 9 3. That is for what? 2 decimal place. Now for 3 decimal places is 1, 2, 3. You stop here. You check the next number. Is it up to 5? No, it's not up to 5. It's just what? 1. So it's 0. You don't need it. So it's returned to 0. And 0, you just clear it off. So what you have here is 7.926. So this is what? 3 decimal place. Can you recall? I'm still using this number for it. Now for a decimal place, 1 decimal place, it means you stop here, right? You check the next number. Is it up to 5? No, it's not up to 5. So it will be what? 7.9. That is what? 1 decimal place. 1 decimal place. So I've seen students that sometimes students make mistake of that. After they round it up to 3 decimal place, since we said that okay, round it up to 2 decimal, 3 decimal, and 1 decimal, they will not use this one. They will round it up to another. Let's assume 2 decimal place, then 1 decimal. They'll use this 7.93 for 1 decimal places. No. After you are done with the question you are given, after you are done with it, after you are done with this question, then the answer you get, you don't need this thing. You throw away. This is 2 decimal places. You take it off. Then you check the next one. So you are still going to use the same question given to you to solve the other one. You are not going to use the answer you get for the first one for the second one. No, use the same question to solve for the first one, second, and third one. So let me just let's look at this one. Let's look at this. Let's assume you are given something like this. They ask us to make this one in 1 decimal place. There's a question I saw here. So let's assume you have like 2 2.99, let's say 432. So you have to make this thing in what? In, let's say you have 1 decimal place, 2 decimal place, and 3 decimal place. So in this one now, so what are you going to do here? 1 decimal place here, that will be, you have 2 points. Let me write this 2 points. I don't want to, 2.432, 2.99432, and 2.99432. So you are rounding this off. You are rounding this off to 1 decimal place. It means you have to write, now what you have to do is that this one is 9, yeah, you have to stop here. But you check the next number. Is it up to 5? Yes, it's up to 5. You make it what? 1. But when you add it to this 9, it becomes 10. No, this is not what you're going to do. So it's going to be 2.9. So when you add 1 to 2.9, that will be 3.0. So what's going to happen is that it's going to go like this: 2.9 plus what? Plus 1. So when you add 1 plus 9 is 10, right? You write 0, you keep what? 1. So 1 plus 2 is 3. So you have 3.0. So it means this one decimal place will be 3.0. Here's 1 decimal place. Now 2 decimal place, the same thing, you have to stop here, right? But this one is not up to 5. So your answer here, this one is straightforward. That is 2.99. This 2 decimal place. Now 3 decimal place, 1, 2, 3. You stop here. You check the next number. Is it up to 5? It's not up to 5. So it's cancelled off. So what you have is what? 2.994. This 3 decimal place. I hope you understand this very well. Let's move on to significant figure. Look at approximating value to a significant figure. And this is, in fact, one of the most confused parts for students in approximation. But you have to know the rules. There are rules that guide this thing. Then I will bring out a Microsoft Word I prepared to for the rules. Now the rule says that all leading zeros are not significant. So let's look at all these rules one after the other. Question under it, then now be able to get an idea of how significant figures work. Now the first one, all leading zeros are not significant. What are they saying here? If for example you are given some, they said you should make this thing in, you are given, let's say you have 0.0034661. You have to round it up to, let me just use small one, 2 significant figure and 1 significant figure. So what do you think the answer will be? It means in this particular case here, this leading zero, you don't need to count it. It will not be among the significant. It will be insignificant. It will not be counted. Now, what is even this significant figure? It's telling you that out of all these numbers here, I want only 2 numbers. 2 what? 2 numbers. So it means you are this one, you are going to write all this one. That one is sure. You will write all this. But normally, students will say, okay, this is what? 0. You now start counting here. This is 1, this is 2. But if these 0 are leading 0, they are not counted. But does not mean you are not going to write them. You will write them, but you don't start your counting from this leading 0. So what you are going to do for 2 significant, you have 0. This is the question you are given, 0.003461. So if I want to approximate to 2 significant, so I will write this 0.00. Now this 2 significant will be 1, 2. I'm going to stop at this 4 here, 34. But you check the next number. Is it up to 5? Yes, it's up to 5. You round up. So you add it to this one, making what? 5. So your answer here is 5. So this is what? This is 2 significant figure. Now the other one, if you have 0.00, the same thing, 3461, you are adding this off to what? 1 significant. So the same thing you are going to do, 0.00 is only this you need, because this is only 1 significant. But you check the next number. Is it up to 5? Yes, it's up to 5. So you are going to write what? You are going to write 3. It's not up to 5, so it becomes 0. So you don't need this. You are going to write 3. So this one is what? 1 significant figure. Now let's now look at what if there's no decimal point here. Let's assume someone. I'm going to give it one. I said 48245. So they ask you to make it what? 1 significant figure and 2 significant figure. Now, indeed, this is a whole number. It's not, there's no decimal point here. So when you now normally now what is here is that 3 5 now they are 0 0. I don't just put it because the 0 after it, because of this 0 point is not counted. You can remove it. But for decimal places, I can decide to put 0 0 here for this, because of this 0 that turned to 0. This one I can put also, I can also put a 0 0 0. This is not needed, it's not counted. So you don't need to put it because of this 0 point decimal point. We are going to go to the next two where it may be in between numbers. But for whole number that does not have decimal point, you are going to write the 0. Now, like this one to one significant, this is, you start from the first one. This is only the one you need. But you check the next number, is it up to 5? Yes, it's up to 5. You make it what 1, add it to make it what 5. So you write 5. Now, sooner to write only 5, that is one significant. No, you have to write all, because all this thing turn to 0. So you have to write 0 0 0 0. So this is what one significant figure. Now, reason why that, why can't I write 5? But you know that if you write 5, 5 is not the same thing as 50,000. Like this 0.3500 is the same thing as 0.0035. So, but here it is not the same thing. 5 and 50,000 not the same thing. So, if the number does not have decimal point, you are making it one significant, you have to write the 0 that others are. Now, two significant figure here. So, this two significant, this 1, 2, you stop here, right? You check the next number, is it up to 5? No, it's not up to 5. So, you run down to 0. So, this will be 0, this will be 0, this will be 0. So, what you have here is 48,000. So, this is what? Two significant figure. So, that is that for that one. Now, let's move to rule 2. The rule 2 says that all middle zeros, the zero between natural numbers, are significant. Now, what are they saying here? So, is zero between natural numbers? Let me show you what they mean here. Let's assume they gave you something like this. Let's say you want this up to let's say you are given 0.0020500. Now, another one you have 30812. This one, they ask what two significant figure, because most time it's two significant and one significant. But in rare cases, three significant. Once you understand these two, those ones will be very easy. Now, solution for the first one. The first one, this is second one. Now, this thing to two significant figure. You see, this 0 is in between two natural numbers, that is two positive numbers. This 2 and 5 is protecting the 0 that you are also significant. It is not leading. Now, this one are leading 0, it is not significant, they are not significant, but this 0 is significant. So, for two significant figures, you now write for the first one, that will be 0.00, these are not significant. 2, this 0 has to be counted because in between them, this up to 5, make it what? Make it 1. You add it to this one, making what? 1. So, this one here is two significant figure. Now, for one significant, is only this you need. This what the other one you clear it off because this is not up to 5. So what is it for one significant? 0.002. This is what? One significant figure. Let's look at number 2. Now, number 2, now this is a positive number. There's no decimal point. Two significant is 1, 2. You have to use the 0. It's part of it. So this one is up to 5. You make it 1. Add it to this one, making what? 1. So 0 plus 1 is 1. So we have 3, 1. Then the others will become 0. That will be 0, 0, 0. You have to put it because this is a what? This is a number without decimal point. One significant, it is only this. Now this is not up to what? It's not up to 5. So everything will turn to what is 0. So one significant will be 3, 0, 0, 0, 0. That is one significant figure. Now that is that for that. Now let's move on to the third rules. The third rule says that trailing zeros, 0 after natural number, for example, the 0 after 8 are not significant, but the 0 between 3 and 8 is significant because it's between two natural numbers. I think this and this, they are the same thing. They are very familiar, so they are the same thing. Like what you are saying here is that if I'm giving something like this, now this one I've explained it earlier, I don't need to explain it again. Now this one, this is where it gets more easier now. Trailing zeros are considered significantly only when there is a decimal point in the number. For example, the zeros after 8 are treated as significant because of the presence of a decimal point. Now, what are they saying here is that in let me scroll down a little bit. I think there's no space again. Let me just clear this one, please. Now, what they are saying here is that if probably they gave you, because where problem always starts from is decimal point. Believe me, it's decimal point the problem always starts from. Now, if assume you are given something like this, that 0.000408000, they ask us to approximate to, let's say, 4 significant figure. 4 significant figure. Then let's say 1 significant figure and 2 significant figure. So what does this mean? Now for 4 significant, you know the trailing zero are not counted. So that one is normal. You write 0, 0, 0. You don't count them. So you start 4, that will be 1, 2, 3, 4. You have to count this also. It's also significant because of this decimal point. So this one is also part of it. So what you have now is what? 4, 0, 8, 0. This is 4 significant figure. 4 significant figure. Because of what? Because of this decimal point. This 0 is also what? Significant. But assume this 0 is at the front here, it is not significant. Get the logic right. Now, the 1 significant will be 0 point. This trailing 0, they are not counted. They are not counted as significant. This is what you stop. You stop here. You check the next number, 0 up to 5. It's not up to 5. So you just write your what? Your 4. 2 significant is will be, this is what? This is 1 significant figure. Now 2 significant, you write 0.0001 to this significant because it's been in between 2 natural numbers. So it's 0. You check the next number, 0 up to 5. It's not up to 5. You make it what? 1. You add it to this one, making 1. So this is what? 4, 1. This is what? 2 significant figure. So let's now look at, let me just give you some questions here. Let's say they said you should round up these numbers to, let's say, what is here is 3 significant figure. I think you have 2 significant. Everything here 2 significant. The first one we have 0.009281. Then you have another one 2.99. Then another one you have, I'm gonna stop here, believe me, I won't go further more than this. So once you just play the video and recap, you'll be able to understand this. Then let me add another 144. So everything here you have to make it what? Round up to 2 significant figure, each of them. Now the first one, number 1, this is number 1, this is number 2, this is number 3, and this is number 4. Now the first one, this one, to 2 significant, you can't. This 20 is not counted. 1, 2, you stop here. This up to 5, you make it what? You 1, you had it to start making what? 3. So what you have is 0.0093. This is 2 significant figure. Now this one to 2 significant, this is counted because it is not 0. So this is 1, 2. You stop here, right? Very well. Now this is done the problem now. You should stop here, but this is up to 9. So when you add 9 to 2.9, this up to 9, you make it, you round up to 1. So it will be 2.9 plus. So when you add it to 1, it's not this 1 here, so it should be 10. Now what they are saying here is that, let me show you something. This 9 here is 1. When you add it up to this 2.9, this 1 to 0, not because you're adding this 1 to 0.9. It means it's 0.9 when you add 1 to it plus 1. That's what it means. So when you add 1 to 0.9, I think it will be 2. 1 to 0.9. That is 2. It should give you 2. So it means it should give you 1. Sorry, 0.9, but that is 1. So that 1, it means this 2.9, this 1 will become, it will now jump here. That 1 will be 3.0. Do you understand what I'm doing now? Let me explain it again. This one is up to 1. You are stopping here, 2 significant. But this one, you have to add it up to this 2.9. So once you add it up to it, it becomes 3.0. You know, I told you that once it's decimal point, 0 is counted as significant. So here would be 3.0 towards to 2 significant figure. Because of this one, you make it 1, add it to 1, making 10, so that will be 3.0. Now for this one and 2 significant, all this one you don't need. This is what you start from here, 1, 2, you stop here. Is this one up to 5? It's not up to 5, so you make it what? You make it 0. So 2 significant, funny enough, 2 significant here, you are going to write what? Number 3 is going to write 300. That is 2 significant. You now wonder that why did I write this 0 again? You have to write it because this 0 is before decimal point. It means what is here is just a whole number without decimal point. So this 0 is also counted. It's part of it. You have to write the 0. You can't write 30 alone. You have to write the 0, so it will be 300. That is 2 significant figure. 1, 2, you stop here. This is not up to 5, so you make it what? 0. So you add it to making what? 0. That will be you make it 0, so that will be 300. Assume there's a decimal point there, you don't need the 0. Now the fourth one, 1, 4 for 2 significant figure. 1, 2, you stop here, right? This one is up to what? It's up to what? It's not up to 5, that will be turned to 0. So what you have here is 1, 4, 0. You have to write the 0 because it does not have a decimal point. I hope you understand how these significant figures work. I'm going to attach this note to this lesson so you'll be able to understand. So let's move on to percentage error.